If you're coming from a language such as C or C++, you're probably familiar with the notion of a struct. And if you're not, don't worry about it. I'll explain it here. But structs essentially are similar to classes, but there's some important differences that you're going to find. First, structs don't support inheritance. When you define a struct, you define its members and its data types and so on, but you can't derive one struct from another. Structs are also value types, while classes are reference types. And if you haven't yet watched the movie where I explain the difference between value types and reference types, you should probably go watch that because it'll make a lot more sense. You also can't initialize the fields of a struct inside the definition. So for example, when you have a member variable inside of a struct, you can't put a little equal sign after it and initialize it to a value. You have to do that outside the definition. Structs are usually used when you just want some small and simple data structure to represent some piece of information and you don't want all the overhead of a class. Now, structs can have properties and methods just like a class can. You just have to remember that they're not really classes. You can't have inheritance. There's all kinds of things you can't do. So let's take a look at a real example. Suppose we wanted to define a data type for representing a point on a two-dimensional surface. Well, we could do that with a class, right? We would say public class point, and we would have an x coordinate, and we would have a y coordinate. You could also have a constructor function. So when someone said new point, they could pass in a value for the x and the y, and that would set the x coordinate and y coordinate to whatever the values are. We could also just simply declare this to be a struct, in which case it's not a class anymore, but everything still works. We've got member variables, we have a constructor function, and everything is fine. So let's go jump over to the code and exercise this. All right, here I'm in my structs example, and I've got my snippet scrolled down to the part on defining structs. So over here in the code, I'm going to just copy these lines right here. And I'm going to copy this structure definition, copy that, and I'm going to paste it over here. So now I've got my struct, which defines a point, and it's got these two private member variables for x coordinate and for the y coordinate. And you can also see that just like a class, I've got my constructor function for the point, and I've also got a property for setting x and a property for setting y. So let's go back over here and copy some code. So the first thing I'm going to copy is this one right here. And I'll scroll down to my main function and paste that in. And what I'm doing here is I'm creating a point, and the variable name is p1, and I'm creating a new point with an x coordinate and a y coordinate both equal to 100. And from the outside looking in, this doesn't look any different than creating a class. Just so happens that this is a struct. So let's go back, get some more code. I can also do the same thing this way. Point p2 is new point, and then I can set p2.x to 50 and p2.y, and this will invoke the getters and setters the same way that I would with a class. So let's go ahead and hit F6, and you can see that the build succeeded. So if we scroll back up, you notice that pretty much the only thing that's different here is I'm using the keyword struct instead of using the keyword class right there on line 8. So then you're probably asking yourself, okay, well, why would I use a struct versus using a class? Well, the main reason is because you've got some small data type. In this case, I've got a point, which only contains really two properties that I really care about setting. So if you've got something small and you don't want all the overhead of a class, or you don't have to worry about things like inheritance and overriding stuff, you can define a struct. You can also use a struct when you don't want to have to worry about things being passed by value or passed by reference. Again, I explained that earlier in the section on value types versus reference types. Structs are value types, so you can pass these around as value types, and the values will be copied, and you don't have to worry about references being changed without you knowing about it. So anyway, that's a quick lesson on using structs. You'll find that in many cases, if you're defining a small data structure, you can use a struct in places where you would normally use a class.